This is our second unit of trig, guys. We're talking about graphing trig functions. So that's what this whole chapter is going to be about, is graphing trig functions. So let's go ahead and get started. I'm going to do this one. I'll let you guys do the next one. I'm going to let you guys see what these functions look like. Now, let's go ahead and figure these out. So if you have your unit circles available or your memory, you can help me out here. So what is, here's my function, cosine of theta equals my function f of theta. So I'm going to turn cosine into a function. Now we haven't really done that, I don't think, yet. But I'm going to say, okay, cosine of theta is a function. I can plug a number in and get an answer out, right? Isn't that what functions do? So let's go ahead and do that, and then we're going to graph the results and see what it looks like. Okay? So what is cosine of 0? No, it's 1. What's cosine of pi over 2? Okay, so cosine is the x value. Pi over 2 is at the top. 0. So 0. Okay, pi is located at the far left, right? There you go. 3 pi over 2 is where? Good, and then 2 pi? 1. Good. All right, so there's our answer. And what's going to happen after 2 pi if I keep going up by pi over 2's every time like that? It's just going to repeat. We call those functions that repeat, we call them periodic. The y values just repeat over and over again. Now there's other numbers in between here, but they're all weird decimals, and I'm just going to skip them. But I'll show you the shape of the graph anyway, but you can always plug in more and get more points to kind of see the shape a little more. But anyway, so let's go ahead and graph those. This is going to be my x-axis, so instead of calling it x, I guess I'll change it to theta. So my x-axis is going to be theta, the input, right? The output is these. So at 0, I'm at 1. That's right here, right? 0, 1. And then when I'm at pi over 2, I'm at 0. So at pi over 2, I'm down here on 0. And then at pi, I'm at negative 1. So at pi, I'm at negative 1. And at 3 pi over 2, we're at 0 again. And then at 1, at 2 pi, I'm at 1. Now, you may be tempted to connect those with 2 straight lines, making a V shape, but it's not. If you actually had more points, you'd see that it's curving as it gets to these. So what it's going to do is it's going to look something like this. So you don't want to connect it with straight lines, okay? They're curved. Now, like Abel said, what's going to happen after 2 pi here is it's just going to repeat, right? Because after that, you just get coterminal angles, which you guys don't remember what that means. It means that they have the same output. So like if I were to plug in the next pi over 2 up, which would be 4 pi over 2, would be, I don't know, maybe like 5 pi over 2. That would just give me the same thing that I got here. It would give 0 again. So what's going to happen then is it's going to come back down here, and then it's going to go back down here, and then it's going to come back up here, and then here. And guess what? It does the same thing over here. Down, down, up, up. So that's what cosine looks like. And it just does that forever. It just wiggles back and forth between 1 and negative 1 on both ends, so it never stops. So I'll put little arrows there. Now, if you have a highlighter, you might want to highlight this portion of the graph, because that's what we started with. And that's kind of a nice chunk to remember, because actually you're going to find that sine looks a lot like that. But I'll show you that if you compare that little chunk that I highlighted to the sine chunk that I'm going to highlight, you'll see that they are a little bit different in some ways. So that is that. Can I erase? Oh, and by the way, we're going to get to this a little bit later, but remember how we said this is called a periodic function just because it repeats over and over again? Okay. Well, that shape repeats over and over again, right? Because of that. That one whole chunk like that, that whole shape is what we call a period of the function. It's a complete period, a complete cycle, if you will. So, all right, so I'm going to let you guys do one. I'm going to let you guys do sine. I printed it for you. All you have to do is fill in your numbers and then graph it. Now, sine is the what value? The y value, right? So use your unit circles if you need to, but you're finding the y values for those angles, and then you're going to plot the results and see what you get. So Armando, what'd you get for 0?
0.
I agree. Brooklyn, what'd you get for pi over 2? Cool. Melanie, what'd you get for pi? And Juliana, what'd you get for 3 pi over 2? And then Alondra, what about 2 pi? 0. The y value. Okay, so let's go ahead and graph these points. I've got 0, 0, right? I have pi over 2 is at 1. So over pi over 2, a point is here. And pi is at 0. 3 pi over 2 is at -1. And then 2 pi is at 0. And if we connect it with a curve, right, not with straight lines, but with a curve, like that. But we know that this is really just going to repeat, right? So in other words, it's going to come up like that. And it's just going to keep wiggling back and forth at those pi over 2 marks. So every pi over 2, it goes from 0 to 1 to 0 to -1 to 0 to 1 to 0 to -1. Just back and forth, bounces up and down, right? And that happens at the pi over 2, the 90 marks. Now, let's highlight a portion. We're going to highlight from 0 up to here, because after that, it's just going to repeat. Now, if I were just to show you the wiggly line, they look exactly the same. And in fact, they are. If you took a cosine graph and just shifted it to the left, it would be a cosine graph. So the key difference is really where they start, okay? Sine starts down here at 0. And if you look back at the graph that we had earlier, cosine starts at 1. But other than that, they have the same pattern. They both go from 1 to 0 to -1 to 0 to 1, back and forth, just up and down, okay? The difference is just in the starting point. So that's what cosine and sine graphs look like. Why do we like graphing? You know, what's the point of graphing? Well, same reason we like graphing any function. It kind of helps you see the general behavior of a function from a bird's eye view, if you will. So here's a little slide that I put to kind of summarize what we looked at. Sine starts at 0, and it goes up. Cosine starts at 1 and comes down, right? That's the difference. But they follow the same pattern of rising and falling. Something that we didn't look at was their domain and range. So I guess we can come back really quick. So domain, if you guys don't remember, that means all the possible values of x. Well, it's just going to keep going to the right forever, right? There's no reason to think that it's ever going to stop. And also going to the left. So the domain is anything. You can have all real numbers is the domain. But the range, the possible values of y, well, as you guys can see, it's stuck between 1 and -1. And you remember when we were doing unit circle, remember I told you sine and cosine can never be greater than 1, but they'll always go in between them. So that's the domain and range for sine and cosine. Now, their highest and lowest values can be altered, and we'll see that a little bit later. All right. Here's some vocabulary for you guys. The top value of the function is called this maximum. The bottom is called this minimum. The line that goes right down the middle, which so far has been the x-axis, is called the midline, but it doesn't have to be the x-axis. Okay. The height from the top of your curve to the midline is known as the amplitude. It's the same thing from the bottom of your curve to the midline. They're equal. And then we talked about what a period is. It's one full cycle. And as soon as you see that shape repeated, then that's another period. So the domain is all real numbers, and it bounces back and forth between the minimum and the maximum. The minimum value is your midline minus the amplitude. So if you take your midline and take the amplitude away, that'll put you at your minimum. If you take your midline and add the amplitude to it, then you get your max. You guys will kind of see that worked out as we go. Let's review some transformations too really quick. What does this do to a function? The graph.
It makes it upward.
Makes it go up. So that's a shift up. What's called a translation, right? And minus makes it go down. So they're both translations, but a plus is a translation up and this is a translation down. And that number there, what did that do to our graph?
Made it wider.
Okay, good. So it's called a compression or a stretch. So it either stretched it vertically, it's vertical because it's outside the function, right? So it could either stretch it or compress it vertically, right? And you guys know what this does probably pretty good by now, right? That flips it upside down, right? So we have reflections, we have stretches, compressions, and verticals. Notice I'm not doing any of the ones on the inside. Remember those ones are the horizontal transformations? Is that ringing a bell a little bit? We're going to put that off on a whole separate day because it's kind of complicated, but the verticals are pretty straightforward. Okay, so let's see. So sine and cosine. Where are their midlines at, you guys? They're on the x-axis, right? That's at 0. But if I were to add a number to it, that's going to move your midline up to whatever that number is, right? So this number here is going to represent our midline then. The k. So whatever number's added or subtracted, that's going to represent the midline of that wiggling curve. Okay? What would this affect if I multiplied my sine and cosine by a number in the front? We said it stretches it, right? So what part of the graph would that affect? It's not going to change the midline. It's going to stretch it away from the midline. So looking at your vocabulary there, what will that affect? It'll affect your amplitude, right? It'll get higher and lower. And that, therefore, will also affect your maximum and your minimum, right? So this is what's going to basically give us our amplitude. Usually the amplitude is 1. So if I were to multiply it by 2, now my amplitude is 2. It goes, instead of wiggling back and forth between 1 and -1, it's going to wiggle back and forth between 2 and -2. Okay? Because it stretched it. We'll talk about reflections in a minute, but for now, we'll just look at those ones. All right. Still need it? Okay, I'll pause for a second. Did I print this for you? Okay, good. These are the steps for graphing, okay? Then we're about ready to do some problems to actually get the graph going. All right, so we're going to start by graphing the midline. Okay, that's the number that comes after the sine or cosine, which is plus k. So we're going to start by just drawing a horizontal line with that value. Then we're going to use our amplitude to find the minimum max. So you take your midline, you look at your amplitude, that's the number in front of the sine or cosine. You're going to go up that much above the midline and down that much below it. And that's going to tell you where your min and max values are. Okay. After that, you're going to draw your curve, and for that, it's helpful to remember what sine and cosine look like. Sine is the one that starts at the midline and goes up. Cosine is the one that starts at the max and comes down. And that's it for now. Okay? So let's go ahead and try some of these. I don't know if we're going to do all of them. We'll see. Probably can get away with just doing the first two, honestly. All right, so let's go ahead and, did I print this for you? No. Okay, so just go ahead and write down the directions there and number 1. And I'll wait for you. So let's start by identifying our midline. There it is. That's my midline. So the midline is going to be the line y equals -2. And my amplitude is 3. So let's go ahead and graph it. Now we're going to be using the same angle values that we used on that chart at the very beginning. It always starts at 0, and then it goes up by pi over 2, and then it goes to pi, and then it goes to 3 pi over 2, and then 2 pi. Okay? Now it's not always going to be those values, and we'll talk about when they'll change at another time, but for the most of our lessons, for the next 4 lessons, they're all going to be that. Okay, it's not going to change. All right, so let's graph the midline. The steps that I gave you guys said to graph the midline first. So the midline is -2, right? So we're going to go down 2, and we're going to put our midline. Now that's an imaginary line. I want you guys to know it's not like if you actually went on Desmos and graphed a cosine function, you're not going to see a dotted line there. All that is that tells us where the middle of our curve is at, right? All right. Now here's the next part. We're going to take our amplitude, which is 3, and we're going to go that far above our midline and that far below. So if this is my midline, I'm going to go up 3. 1, 2, 3. Right? So this distance here is 3, right? And that puts me where?
1.
That puts me at 1. That's where my maximum value is going to be. And then I'm also going to go down 3. 1, 2, 3. And that's going to be my minimum value. That's my amplitude. Okay, so step 1, graph your midline. Step 2, graph your min and your max using the amplitude, right? Step 3, we're going to draw our curve. Now to do that, you need to know, are we looking at a cosine graph or a sine graph? We're looking at a cosine, right? And cosine starts at the what? The max, and it goes down after that, right? So we're going to start up here at 1, and it's going to go down to the midline for the next one. So at pi over 2, I'm going to be on the midline. And then at pi, I'm going to be on the minimum. And now if I go over one more, where will I be? Back up to the mid. Over one more is going to put me back up to the top. There's my curve. And once you have that, just go ahead and sketch the rest of it. Just estimate the rest, but that's about what it looks like. So all I'm really going to be looking for is where it starts at. Okay? So that's a cosine graph. Yeah.
I'm sorry, I'm just kind of confused how you put the points.
Where the purple dots came from? Yeah. So it's always going to go from, it's going to bounce back and forth between the max, midline, and minimum, right? So if I start here, it can only go down to the midline, and then to the minimum, and then back up. It's like a bouncing ball, boing, 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 right? Now, when does it hit the midline? Over 1. So it's over 1, down to the mid. Over 1, down to the min. Over 1, up to the mid. Over 1, up to the max.
Is this for cosine?
Yeah, and that's actually true for sine as well. But the only difference is where it starts. Sine starts at the midline, and then it goes over and up and down, whereas cosine starts at the max. But everything else is the same. All right, let's go ahead and write down number 2, same instruction. It says state the domain and range. The domain, what's the domain of this thing that I just graphed? What are the possible values of x? All real numbers, darn. The range, what y values is it bouncing back and forth between? That's right, it goes from 1 to -5, right? So it goes from, -5 is less than or equal to y, which is less than or equal to 1. And notice it is equal to. It actually does reach that value. It's not like an asymptote or something. So we'll put an equal to sign there. All right. Now we can write down number 2. All right. I'm going to change number 2, though, if you guys don't mind, okay? A little bit after I just asked you to write it. Can we change this from a 3 to make it a half? There we go. Let's make it a half. All right. So first of all, what's my midline, guys? 2. That's my midline. And the amplitude? Amplitude's half. Let's go ahead and graph. So we're going to set up our graph. Same x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. By the way, you could do degrees as well. That would be 90, 180, 270, 360. You could do degrees as well. It doesn't matter. Same answers. All right. We're going to plot our midline. My midline was 2, right? So I'm going to go up 2. Now I'm going to use my amplitude. Now my amplitude is a half. So if this is 1, this is 2, this is 3, then half is going to be like right about here, right? So this is going to look a little bit weird, but we're going to go up a half from the midline. We start at our midline and go up a half. So it's going to be at 2.5, right in between 2 and 3, right? Where will the minimum value be? At 1.5, right? Between 2 and 1. Okay. So this is what kind of a function? Sine, and where does sine start? At the midline. And where does it go after that? Up, right? So we're going to go over 1, up 1, over 1, down 1. When I say down 1, I mean down 1 space, right? Over 1, down 1, over 1, up 1. So that's a sine wave, right? That has, it starts at the midline of 2 and it goes up by halves and down by halves. And then we just kind of continue the shape after that. All right, domain. Range. What's the lowest value? 1.5. And what's the highest value? 2.5. So it just bounces back and forth between 1.5 and 2.5. Now, like I said, sine and cosine usually stay between 1 and -1, right? But because the amplitude, that changed it. Okay. All right. you guys practice a couple of them. You don't need to do all of these. Let's have you do the bottom two here. Go ahead and try those out for a bit. You guys, let's see how things went. All right. So, Jalissa, what's our midline on this number 2 here? That's right. So I'm going to go down 2. Put a dotted line there. Nora, what's the amplitude on this number 2? 1. So there's no number in the front, we can assume it's a 1. So from the midline, we go up 1. And that's going to give me my max, and then from the midline, I go down 1, and that's going to give me my minimum. So my max is at -1, and my midline is at -2, and my minimum value is at -3. All right, next, Edwards, where do I start for a cosine function? At the max, yeah. So that's going to go there. And then from there, it's over 1, down 1, over 1, down 1, over 1, up 1, over 1, up 1, and then connect the curves and just continue the pattern after that. So, Amanda, what's the range of this function? Starts at -3 and goes all up to -1. Let's go ahead and take a look at the next one there. So Eric, where's the midline for this one? Cool. So we're going to have a horizontal line at 1. Tavier, what's the amplitude on number 3?
3.
Yep. So that means I'm going to go up 3 from there, which puts me at 4. And then I'm going to go down 3, which puts me at -2. So it goes from 4 to -2. Connor, where does sine start at? Midline. And Abel, with sine, you can either go down or up, but I told you that sine always goes up. And we're going to learn right now that that's not always true. But there's our curve. And so the range would be from -2 to 4. All right. So when I'm grading these, you guys, what I'm looking at is I'm looking at, did you get the midline? Did you get the correct minimums and maximums? Did you have the correct starting location and then shape? Now I know that might sound silly, but with cosine, if you start at the top, you're only going to get one shape. But with sine, some people might forget and go down. That would, even though you start at the right place, you would have the wrong shape at that point, right? So that's typically how I'll be grading these. Now, when we get to horizontal transformations, that's going to change these angles. And that's another point that I'll be grading on. But for the most part, that's how you're graded here. Oh, and of course, can you correctly state the range? But sometimes I ask that, sometimes I don't. All right, so let's move on. You guys remember vertical reflections, right? It just flips the graph. So if sine usually starts at the midline and goes up, if I were to flip that upside down, it would start at the midline and go down, right? So when you have a negative amplitude, you start at the midline and go down. Okay? Now for cosine, cosine usually starts at the max, right? But if I put a negative in the front and that flips it, that means I'm going to start where? At the minimum value, and I'm going to go up. Okay? So, if you have a negative in front, for sine, midline go down. For cosine, start at the min. All right? That's the only difference. The reason it does that is because it's a reflection. So, let's do one really quick here. All right. I'm not going to ask you to like write out the midline or amplitude this time. I just want to make sure that we get the general graph correct. So let's go ahead and draw a graph really quick. And we're going to have 1, 2, 3, 4, 5 points, is it? 0, pi over 2, pi, 3 pi over 2, and 2 pi. We don't need a left. Okay. Okay, so I'm starting at, my midline is at what? Good. So let's draw a dotted line at -3. What's my amplitude? -1. So that, and we can ignore the sign here because it goes up and down, right? So I just need to go up 1. I missed my line there a little bit. And I also need to go down 1. Up 1 and down 1. And this is what kind of a function? Sine. So it starts at the midline, but since it's negative, now it goes down. That's the only difference. So midline, over 1, down 1, over 1, up 1, over 1, up 1, over 1, down 1. So the only difference is it went down instead of up to begin with, because it was vertically reflected. Okay. And as you guys know, when I say the word start, that's arbitrary. These graphs don't really start anywhere. We're just starting at 0, but they go on forever in both directions. All right. Cosine. All right, what's my midline? 0. So if you don't have a number there, then you can assume that it's 0. So my midline is 0. My amplitude is what? 2. So up 2, down 2. Hey, what's up, buddy?
Thank you.
So my max is at +2, my min is at -2. This is cosine, but it has a negative in the front. So where do we start? At the minimum. You start at the minimum. So it's going to start down here, and then over 1, up 1, over 1, up 1, over 1, down 1, over 1, down 1. Same shape, it's just upside down now. That's correct. So when you have a negative in front of a cosine, you start at the min. And when you have a negative in front of the sine, you start at the midline still, but you go down instead of up. Okay. Here's a couple for you guys.